Come on. Somebody wanted to be in the video. There he is. You want to learn about logarithms? He's like, I prefer not to. Well, so we are starting notes on identifying inverses of logarithms and exponentials with transformations. So this is a little bit of an extension of where we left off with just the anatomy of a logarithm and how we were graphing exponential functions as well. So we're going to do this video in sections where you're going to try some pieces. You're going to match these graphs and you'll make your little statement. I can tell that it's this graph because blah. You notice these transformations, you know these features, and you can move on and do 1 through 5 there, and we'll come back. All right, how did you do? We're going to look at 1 and 2, and we matched number 1 with B, number 2 with D. The explanation there, I'll admit, is pretty lacking. If you said similar things in your answers, so this exponential function is shifted down 4 when it is because of that -4, and the exponential function for D is shifted up 4, then I would just challenge you to be a little bit more specific. So this exponential function is shifted up 4 for D, and you can tell that because exponential functions normally hug their parent functions, that is normally hug the x-axis, and we can see that just based on the scale of some of these, that some of these do a better job of hugging the x-axis, and we would normally get something that looks like this. If I can draw on D just a little bit, if it were the parent function. So we would just explain that it's above the x-axis, or it's going to be below the x-axis, because we know that that horizontal asymptote restricts the base of those exponential functions. So a little bit more explanation there. Hopefully you did better than I did with that, and again, it was a teaching opportunity. On number 3 and 4, I gave my match there for number 3A and number 3 and letter A, and number 4 and letter C. So when you're comparing these two, they have a little bit of a different relationship than the exponential functions did, whereas you could tell that one was above the x-axis, one was below the x-axis for the exponential functions. On the logarithms, you could see that one was on one side of the y-axis, which was C, with the right side, and then the other was on the left side of the y-axis. So you could see a shift left or right. The C is going to be the function with, and I'm going to use y instead of f of x, with log base 2 of x minus 1 plus 4. And A is going to be the one where we shift that, all those points left 1. So we're going to have a plus 1, y equals log base 2 of x plus 1, and then minus 4. So this plus 1 is in our argument, and that's what shifts all the points left. Remember, that argument is just what is inside the logarithm. It's harder to tell with A that it's shifted down 4, but when we compare that to our other option, C, C has to be the one with plus 4, not only because of the shift left or right, but because it's much further above the x-axis, where the x-intercept n is hitting that point. So I hope you didn't graph these as well. That's one thing I forgot to say. And when you do this practice on the next page, don't graph this with like a calculator or something like that. It's gonna defeat the purpose of you really looking into these problems critically. And here's another reason that you shouldn't graph them, because 6 and 7 have some more analysis for you. And I'm pairing transformations and inverses together, because you're gonna see transformations in inverses and vice versa. So when you look at 6a, explain how you know that, what's going on with y equals -8 as the asymptote, the horizontal asymptote on 6a. Then when you try 7, if you don't know already, make sure you isolate the exponential function first before you start converting it to a logarithm. That's going to help you. So that's my hint there. Try your best to do that one. If you have to watch the video and that's your first time seeing that, then that's okay. We'll talk about 7 as soon as I give you a chance to try 6 and 7. Alright, so I actually forgot something before we move on to 6 and 7, and that was with number 5. What's the ordered pair for point M on the graph above? And you can see the math there. The main thing you had to realize was point M was on the x-axis, so it was an x-intercept. And with that information, you could substitute in 0 for f of x using the equation from number 1, because that's the one that matches with the point on M, the graph B. And then solving that is just using the 1-to-1 property, which is just 2 to the 2 equals 2 to the x plus 1. So x plus 1 has to equal 2, therefore x equals 1 and M equals 1. So hopefully you got that. With number 6, the asymptote of g of x is y equals -8. And I just explained it by saying what the parent function is and what that horizontal asymptote is. So if we subtract 8, like the function is saying, from the y values, -8, then we just move all those y values down from the parent function. Actually, the parent function is how we are tackling b as well. So we've got a separate function, h of x. How can we tell what the x-intercept is for h of x? And if we know that on logarithms, the parent point that is always true no matter what base we have is going to be 1, 0. So we're just going to shift 1, 0 right 2, because that's what -2 inside the argument means, and then down 1. So this point ends up at 3, -1. And lastly, we have this finding the inverse function to g of x. And g of x is going to be up here in blue. This function, which I copy. So if you don't remember how to convert or how to find an inverse, I list those steps here. So you kind of have 3 sections to it. With this pink notation, or with this pink writing, we have turning like that function notation g of x into just y and x. So you can easily swap them when you're able. And that's the key thing with these logarithms and exponential functions. And really with any inverse operation. We can't convert this right here. We can't convert this by just swapping x and y. That wouldn't help anything, because we can't turn that result into a logarithm. we can only turn something that looks like this into a logarithm, because one side is just a base and an exponent, and the other side is, well, it doesn't really matter what the other side is, it's just a quantity. Because we can put that quantity, y plus 8, into the argument of the logarithm when we convert it to a logarithm. And you all know how to convert this to a logarithm. You use the base 4, you use the exponent as what the logarithm equals, and you've got your conversion. And then in the third step, we're just going to isolate x so that we can finally swap x and y. And at that point, we'll just tidy it up with a little g to the -1 notation, and that's all. And the same goes for like converting that back to an exponential. The key is make sure you've isolated, it's this step that I have boxed here in yellow. Make sure you've isolated your base and exponent, or make sure you have isolated, like in this other orange step, your logarithm and the base 4 with the argument. Another thing you might notice to wrap up this video is we maybe didn't have to do all this inverse like calculations if we could just pay attention to the transformations on the function g of x. So g of x is moved right 1, so we can kind of get the gist of what's going on here. So it's moved right 1 from its parent, and then down 8. So we'll just say it's about right here. It's about sitting there on our graph. And if we want to graph the, I know you're looking at this little thumbnail on the side, but if we want to graph the logarithm, then we would need to move it, would we move it left 1 or left further? Because we need to make it match up with this, you know, line of symmetry that is y equals x. We would have to move it left 8 and then up 1. So it would match. And you can kind of imagine that in your mind's eye, or with a little sketch even, which sketching is huge. It's great. And then you could formulate your equation from that and just double check it with, you know, what you have for your sketch, what you have for your original g of x, and you can get this as well. So yeah, you can go graph it on Desmos, you can go graph it on anything, but we're looking to deepen your understanding about what's going on with these inverses and transformations. Now, when you do this practice, you're just doing a little, you know, housekeeping as well. Make sure you're comfortable writing in behaviors. Make sure you're comfortable writing the domain using interval notation. And you have some examples here for those things. I know all real numbers is not interval notation, but if you use interval notation on all real numbers, then you're going to get -infinity to infinity, so that's easy. But try 4 and 5. I'm sure we'll be talking about them in class. Good luck, and I'll see you all later. Bye.